Okay, in this video we're going to look at special triangles. There are two special triangles. The first one is called the 45-45-90 triangle, or 1-1 root 2, and I'm going to show you why. So if you have a right triangle and one of the angles is 45 degrees, that would make the other one 45, because the angles add up to 180. 90 plus 45 is 135, and then what's left over is another 45. So now we have an isosceles triangle. And so we're going to do something that's convenient here. We're going to let one of the sides equal a length of 1. So we're going to do this side, length 1. Because it's isosceles, those two angles are equal, then this also has to be length 1. And from Pythagorean theorem, okay, the hypotenuse squared equals that squared plus that squared. So that's going to equal the square root of 1 squared plus 1 squared. Okay? And that then just equals root 2. Okay? So now we've got a 1, 1 root 2 triangle, or 45, 45, 90 triangle. So that's the name of this triangle. It's 45, 45, 90, or 1, 1 root 2. Okay, so we'll refer to that triangle as one of those two names. Now there's another triangle that would be useful in the future for when we're graphing, and that's instead of letting one of these two sides equal 1, if you let the hypotenuse equal 1. Okay, so we could have a little also here in brackets. So if we do same type of triangle, okay, if I let this side equal 1, so that's 45, 45. If that side equals 1, well, we can use the fact that they're similar triangles to figure out these two sides. You can use Pythagorean theorem, but it's easier just to work from this one. In order to turn this side into a 1, I would have had to have divided this side by root 2. So root 2 divided by root 2 is 1. And for similar triangles, the ratios of side lengths are the same. So if I'm dividing this by root 2 to get 1, then I have to divide these two by root 2 so that we have a similar triangle. Otherwise, you could go through and use Pythagorean theorem with these two sides both equal to x and trying to solve for it. Okay, so that's an alternate one that we can use in the future. So now we want to look at what the trig ratios are for sine 45. So sine 45 and cos 45 and tan 45. So what's useful about this triangle is we can get exact values for this. If you plugged in sine 45 on your calculator, so sine 45, you're going to get 0.70710. You can't really tell exactly what that number is. And the fact is, that is an irrational number, so you cannot tell. It's like pi. So pi, you can't tell exactly what it is. You can only estimate it if you're writing down numbers. Same with root 2. So if we look at this triangle now, sine of 45, it equals opposite over hypotenuse. So sine 45 equals 1 over root 2. So now we have an expression for the exact value of sine 45. Cos 45 is adjacent over hypotenuse, so it's also going to be 1 over root 2. And then tan 45 is opposite over adjacent, which is just 1 over 1, which equals 1. So these are what we call the exact values. Okay? Exact values of sine 45, cos 45, and tan 45. Well, tan 45 is not hard. 1 is exact. These ones, now the approximate values, we put a little dot over the equal sign for approximate. We just saw 0.707 about, and this one's also 0.707. Okay, so those are the approximate. Okay, so that's the easier special triangle. Now the second special triangle, the way I like to get it is from an equilateral triangle. So I draw an equilateral triangle best I can here. And we all know that the angles in an equilateral triangle are each 60 degrees. And they're 60 because the total sum has to be 180. And 180 divided by 3 is 60. So there's 60. There's 60. And I'm going to take this triangle. I'm going to make each side equal a length of 2. 2, 2, and 2. Now I'm going to cut it in half. Yeah, actually, I'm going to just put a solid line down there. If I cut it in half, then this angle becomes 30. This is a right angle, and this side length here becomes half of 2, which is 1. So now I've conveniently got all 3 angles and 2 sides. The third side, well, it can be obtained through Pythagorean theorem. Okay, so that side's 2, that side's 1. This is the hypotenuse, so we have 2 squared equals 1 squared plus, I'm going to put a question mark squared, because that's what this side is, right? Okay, so the question mark is then going to equal the square root of 2 squared minus 1 squared by bringing the 1 squared over and then square rooting to get what's unknown, and that ends up being root 3. Okay, so that side is root 3. Okay, so this triangle has a couple names, and we're going to draw it out here now nicely, so it's just the one triangle. The way I get it is from an equilateral triangle, but then the actual triangle is just the one side, so it's 1, 2, root 3. Okay, so 60, 30, and 90 are the angles. Okay, so its name is basically the 30, 60, 90 triangle, or it's the 1, 2, root 3 triangle. Okay, and we had an also with this one where the hypotenuse we wanted to be is 1, so later on it'll be useful to have the hypotenuse of this one equal to 1. So I'm just going to put a little also down here. Okay, so this is the triangle you want. This is another one. Okay, so if we made the hypotenuse in this one 1, so 60, 30, 90. So I make the hypotenuse 1. Sorry, side of the camera there. So I make the hypotenuse 1. It used to be 2, so in order to turn a 2 into a 1, I'm going to divide by 2. Because they're similar triangles, the side lengths are going to be the same ratios. So divide that by 2, I'm going to have to divide the others by 2. So this becomes 1/2, and this one becomes root 3 over 2. Okay. Now we want to look at the trig ratios for 30 and 60 degrees. Okay. So sine 30, cos 30, tan 30, and sine 60, cos 60, and tan 60. Okay, so sine 30. 30 is up here, opposite over hypotenuse. Sine 30 is 1/2. Cos 30. Cos 30 is adjacent over hypotenuse, so it's going to be root 3 over 2. And then tan 30 is opposite over adjacent, so 1 over root 3. Okay, 60. Sine 60, opposite over hypotenuse, root 3 over 2. Cos 60, 1 over 2. And tan 60 is root 3 over 1. Okay. Now these are the exact values. Okay, so you could look at the approximate values for these. Well, 1/2 is obvious. It's not approximate, it's actually 0.5. root 3 over 2, well, that is, I believe it's 0.866. So we can check on our calculator. You can do two things. You do cos of 30 or do root 3 over 2. It should give you the same thing. Okay, so cos 30 equals 0.866, or square root 3 divided by 2 equals 0.866. Okay. Okay. And I'm going to put it the same thing here because root 3 over 2 shows up twice. Okay. And then we have 1 over root 3 and then root 3. So 1 divided by root 3 is equal to 0.577 approximately. And then root 3 itself equals 1.73 approximately. 1.732. Okay. So these are the special triangles and the trig ratios correspond with them. Now what you want to remember are these exact values. So you've got root 3 over 2, 1 over root 3, 1 half, root 3 over 1, which is just root 3, I should write, just root 3. And then we have 1 over root 2 and 1. So that list of special of trig ratios for special angles is a good list to remember and try to relate to the triangle. So every time you see 1 over root 2, okay, that repeats itself twice, 1 half root 3 over 2, and 1 over root 3 and root 3. So that is the list of trig ratios that are exact values from the 30, 60, 90 triangle or the 45, 45, 90 triangle. Okay, so if I ever asked a question, or you were asked a question, what is theta when cos theta equals root 3 over 2? Well, you go back and draw the special triangle, or you go back to your list here. So your list, well, cos of what equals root 3 over 2? It was 60. Okay, or you go back to the triangle and draw your 30, 60, 90 triangle, and root 3 over 2, cos is opposite, or sorry, adjacent over hypotenuse, so it would have to be 30 degrees. Okay, so that implies theta equals 30 degrees. Okay, if you had something like sine theta, so let's say 2 root 2 times sine theta equals 2. Well, then you would divide both sides by 2 root 2, and you'd have sine theta equals 1 over root 2, and by looking back we know then that that implies theta equals 45 degrees. Okay, and that's it for special triangles.